Hi everyone, welcome back to Java lesson 08. My name is Tashwanchu and I'm accompanied with my friend Ugen Tinle. Today we are going to learn string manipulation in Java. Today we are going to learn string manipulation in Java. So under string manipulation, we are going to study string class and string buffer class. Now, in the previous lesson, that is lesson 07, we have learned on the packages and modifiers. So, if I give a recap on the lesson 07, uh, what are packages? Packages are nothing but they are just the folder structure uh, that you separate the different modules in your project. And modifiers are the SS permissions, and we have four modifiers. We have four SS permission modifiers. They are default, public, private, and protected. Now today we are going to discuss on these string manipulations in Java. And on string, we have string class and string buffer. Now these string and string buffer classes are present in the java.lang package. So in the previous lesson, we have gone through the packages. So this string and string buffer is a predefined class. So it comes with the Java software. So at the time of Java installation into your system, so these packages will be generated. Okay. Now this string and the buffer class, and there are other classes also. So for this, we are going to study this string class and string buffer class because these two are the most frequently used. Now, so under this string manipulation, we are going to discuss six cases. Okay. We are going to discuss the final class, then approaches to create object with the help of using creating the object with a string, and we also want to discuss on the immutable and mutable nature of the string classes and the string object, and we also discuss the tree string method and equals method and conversion of the string, that is uh, string to how to convert string to string buffer and string buffer to string. Okay, so we will discuss these six cases in this lesson under string manipulation. Now, let's start with the case number one. Uh, Case one. So under case one, let's discuss about the final class. Final class. Now, I have told you that we are going to discuss on string and string buffer classes. Now, where are those string and string buffer classes? So I have already shown you last time. So let me show you again. It is usually it is present in local disk C. For your convenience, I have just take it here. So it is inside src folder and in the Java and inside this java.lang. Here we have uh, string and string buffer classes, which is present predefined in the Java. It is present in java.lang package. Okay. Now, in the case number one, now for now this string and string buffer classes are present in the java.lang package, and because since I've opened this string class and we can see here the string class has been declared with a final. This string buffer class is also declared with a final modifier. So therefore, in the time of the inheritance concept, I've told you that if you are giving the class as final, you are not able to extend that final class. So therefore, this string and string buffer is not able to extend. not able to create the subclasses for the string and the string buffer. So this is just for your for your information regarding the case one, the final classes. Okay. Now case two is here string and string buffer classes are final. It can't be extended. Okay. Now case two is uh, here I've mentioned case two is regarding the approaches to create object. Okay. Approaches to create object. Now for this string class, for this string class, for this string class, we have two approaches to create the object. That is, number one is without using the new keyword, and number two is using the new keyword. Now, in the previous lessons, I have told you that object creation. So there are different ways of creating the object. So we can also create a string object without using the new keyword, and we can also create a string object with the help of new keyword. So two approaches to create the string object. Now, now, now how we can create a object, string object without using the uh, new keyword is that, for instance, let's say we have string s1 is equal to, let's say, trashy, and string s2 is equal to, let's say, sonam. And we have another string s3, which is equal to trashy. So this is one way of creating object, uh, string object without using the new keyword. This is for number one. Now, how we are going to create a string object with the help of new keyword is that just string, let's say s1 is equal to new string, then just give trashy, just copy this, so just say string 2 and string 3, then let's say this is sonam. Now this is the way of creating the string object without using the new keyword, and this is the way of creating the string object with the help of new keyword. Now I'm going to tell you the difference why we have two approaches, the difference between creating the object new keyword. Now let's discuss this first. Now in entire Java, when you create a string object without using the new keyword, the objects are created in the SCP memory, that is string constant pool. Okay, so when you're creating an object this way, so the object are created in the string constant pool memory. Now let's say I've here on PowerPoint. Now let's say we have a string constant pool memory. So this SCP is a type of memory for Java object creation. So SCP is the string constant pool memory, and I'm going to show you the behavior of this SCP memory. Now let's say you are creating the string s1 object. String s1 is equal to Tashi. Here we have string s1 is equal to Tashi, string s2 is equal to Sonam, string s3 is equal to Tashi. Now, how these objects are stored in the SCP memory, I'm going to show it here. Okay. Now, let's say we have a SCP memory. This is the SCP memory. And when we are creating string s1 is equal to Tashi, so this Tashi object will be created in this SCP memory uh, with a reference variable s1 pointing to the object with the content Tashi. So this is the behavior. You are creating the second object, that is string s2 is equal to Sonam. Now, before creating the object in this SCP memory, so it is always checking if the object with the content Sonam is already present in the memory or not. Now, if it is not already present in the SCP memory, then new object is created with the content Sonam, where a reference variable s2 uh, pointed to the Sonam. So Sonam object is created, new object Sonam is created since Sonam is not present in this SCP memory. So S2 is pointing to Sonam. Now the third object, it's when we are creating the string S3 is equal to Tashi. Now first, it will check if the object with the content Tashi is already present in the memory or not. Now if you see here, so Tashi is already present in the SCP memory. Now, since content Tashi is already present in the SCP memory, it is not going to create a new object. Instead, it will reuse the previous object, where reference variable S3 will point to the previous object Tashi. So this is how SCP memory is behaving. Okay. Now this is regarding the object creation without using the new keyword. So if you are creating the object without using the new keyword, then the objects are created in the SCP memory, where the point that you have to remember is in SCP memory, it is always checking if the previous object is present or not. And another point that you have to remember is SCP, that is string constant pool, to not allow duplicate objects. So if there is duplicate, it will point to that previous object. So this is the behavior of the string constant pool memory. Now, that's all with this creating object without using the new keyword and behavior of object creation in behavior of these objects in the SCP memory. Now, the second one is uh, using the new keyword. So when you are creating objects, string objects with the help of new keyword, then uh, then these objects are created in heap memory. Unlike the first one, now when you are using the new keyword, the objects will be created in heap memory. Now in entire Java, when you create string object using the new keyword, the objects are created in the heap memory. So in heap memory, it won't check the previous object. Instead, it is going to create all three separate objects. And the point you have to remember is heap memory allows duplicate objects, duplication of the objects, and it will not check for the previous objects. Now the behavior I'll show you here in this PowerPoint. So heap memory, creation of the string object with the help of new keyword. Now let's say this is the heap memory. Now when you are doing string s1 is equal to new string with the content Tashi, it will be created with S1 pointing to the object with the content Tashi. Now, when you are creating another object that is S2, string S2 is equal to new string sonam with the content sonam. Again, the content is created without checking the previous whether it will not check whether sonam is present in this heap memory already or not. It will directly create sonam with reference variable S2 pointing to sonam. Now, when you are doing S3 is equal to new string Tashi, then another Tashi object will be created in this heap memory without checking for the previous object. So therefore, and I mean this S3 pointing to Tashi. Now, if you see the difference between the string constant pool memory and the heap memory, so we can see here clearly that in the string constant pool, duplication is allowed. Duplication is not allowed. In the heap memory, duplication is allowed. So here we have two Tashi objects being created. So this is the difference between creating object using the new keyword and without using the new keyword. So this why there is this kind of concept is because it is required in the project developments. Okay. Uh, I think that's all with the approaches to create a string object that is without using new keyword and with the help of new keyword. Now, we have another class that is string buffer. Now, to create the string buffer object, there is only one approach, that is with the help of using the new keyword. So, as I have already told you, when you are creating the object with the help of a new keyword, it will be the object will be created in the heap memory where it will not check for the previous object and where duplication is allowed. So let me just show you one example regarding this creating object of the string. Let's say we have just remove this. Let's say we have class test and let's say we have let's create a string object here. Strng string s1 is equal to, let's say we have Tashi. Let's just copy this. Now let's say this is second object s2 with the content sonam, and we have Tashi reference variable s3. Now let's try to print those uh, so let's do this afterwards. So just let's do the simple example here. So let's just print system.output print ln. Then let's say we have s1. So this first approach is creating the object without using the new keyword. Now the second approach is let's create a string object, let's say s2, with the help of new keyword. This is how we do. And let's say we have something like Kinley here, and let's try to just copy this. Let's just try to it here, and let's try to print s2. And these are the two approaches to create a string object, and we have one approach to create a string buffer object, that is string bu string buffer sp is equal to new string bu string buffer object. Let's say we have content. Let's just try to copy paste the previous, and let's say we are printing sb. So this is just the approaches regarding this case 2. I'm just showing the simple example, creating the string object two approaches in creating the string object and one approach is in creating the string buffer object. Now let's save this and let's try to run this code. Okay. It is in CD Java training. CD training. Yeah, training practical. Just clear this. The functional story. So we have a trace class here. This, so let's compile. Compile successfully. So we have the test class. Now here we are able to print. So this is the three ways of creating the object. String we have two approaches and string buffer we have one approach. Now it is I'm going to give you the information regarding this equal to operator. Under this case 2 we have this operator. We have this operator, okay, equal to operator. Now what does this equal to operator, so what is the link? So this equal to operator deals with a string only, so that's why I want to discuss equals to operator. So yeah, my friend has already discussed regarding these operators. So now when it comes to this equal to operator, it is dealing with a string object. Frequently it is used in the it is used to deal with a string. So let's try with the um, above objects. So here I've already told you that this, let's try to compare these different objects, three objects with the help of equal to operator. For this without using the new keyword. Now let's say when we do s1 equal to s2, so what it will be? So this equal to operator return type is always boolean. Okay, so when we do s1 equal to s2, what it will uh, return is that, so here if you see s1 and s2, so what this equal to operator does is that it does reference, it does the reference comparison. Now here if we see, I mean here if you see s1 and s2, instead of comparing this content Tetashi and Sonam, so with the help of this equal to operator, it will compare the reference variable. So how it will be checking is that, since when we are creating the object without using the new keyword, it is created in the SCP memory. So we have seen that. So when we are creating this S3 object, that is Tashi, so it is referring to the previous object Tashi, and it is pointing, this S3 is pointing to the Tashi, that is previous object. Now if we see here, when we are doing S1 is equal to S2, so this S2 is pointing to different object and this S1 is pointing to different object Tashi. So that's why is going to return false. Is going to return false. Now if we do S1 equal to S3, now what will be the return type? What it will return is that, if you see here, we have S1 and S3. Now we can see that S1 is pointing to object Tashi. Now if you see here, S3 is also having the content Tashi. Since they are having the same content, so this S3 will be pointing to the same object Tashi. Since these two reference variable S3 and S1 is pointing to the previous object Tashi, so it will return true. So it is regarding this diagram here. So S1 and S3, S1 and S3 is pointing to same object Tashi. So that's why it is returning 2. Since S1 is pointing to Tashi and S2 is pointing to Sonam, that is S1 and S2 is pointing to the different objects. So that's why it is returning false. So if we do S3 equal to S1, then it is also going to return false. Now this is so this approach. Now for this approach, that is creating the string object with the help of new keyword. Now when you deal with this equal to operator with this object with a new keyword, the behavior will be different. So this is always heap memory, and this means always STP memory. Okay, just remove this. So let's check for this string object with a string object created with a new object, new keyword. I mean. Now let's try to compare S1 equal to S2. Now if you see here, this is the heap memory. So when we create the string object with the help of new keyword, the objects are always created in the heap memory. So in the heap memory, so the behavior of the heap memories I've shown you here. Tashi object is already there, but when you are creating the same object Tashi, it is not going to refer to the previous object, just it will simply create the duplicate object here. So that's why, so these are pointing to the independent object. So in entire Java, when you are dealing with this equal to operator with object creation with a new keyword, it is always going to return false. So here we have seen that in the entire Java, so this reference variable will never point to the same object, and it will point to the independent object. So that's why in the entire Java, so this will be always false. Whenever if we do S1 equal to S3, so this will also return, this will also return false. Now if we do S2 equal to S3, this will also, this is also going to return false. So this is just some of the points that you have to remember the behavior of these string objects, the STP and the heap memory. Well, we're done with this case 2, that is approaches to create string object. Now let's discuss the case 3. Okay. Now case 3 is regarding the uh, immutable, IMUTA, the immutable, and MUTABL, mutable, nature of the mutable nature of the string and the string buffer class. So in this case 3, let's discuss the mutable and immutable nature of the string and the string buffer classes. Now for your information, so once you create the string object, then the data is fixed and cannot be manipulated or modified. Okay, this is the point that you have to remember. When you are creating the string object, that data is fixed and it cannot be manipulated. Now, whereas when you create the object with the help of string buffer, so that object can be manipulated or modified. Now, here the mutable nature and immutable nature of a string and a string buffer comes. So, for this immutable and mutable nature of the string and string buffer, I'm going to explain you with the help of one simple program. Okay. Let's say we have a let's say we have a class test, and let's just remove this. Let's check for the immutable nature of the string. So this this behavior is called immutable nature. Now let's create one string object. Let's say s1 is equal to, let's say we have Ashi. Let's try to modify this s1. So let's try to concatenate something to this s1. Let's say we have s1 dot con ch. So this concate is a predefined method which is present in the string class. Okay, this is predefined method. Now let's try to concatenate some string here. Let's say I'm going to concate function. It's just to show the uh, mutable nature and immutable nature of the string classes. Okay, so here we are creating the object Ashi, and here we are trying to modify or manipulate this string object. That is, we are trying to concatenate something to this Tashi. That is, we are trying to concate this Wangchuk to Tashi. Now let's try to print this system output, and let's try to print this S1. Now we can guess the output here. So and let's say we have let's try to create another object with the help of for the string buffer, that is string, you have a string buffer sp is equal to new string 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 buffer. Then let's give the content as common. For this string buffer, we have a predefined method, that is append. So inside string buffer, we don't have concate. So we have append method. So let's try to append. So no, let's try to append one to here. And let's try to print. Let's try to print this as B. And guess the output. Okay. For now, just remove this. I'm going to explain you. So just save this and let's try. Just save this. So what we are trying to do is we are creating the string object here, and we are trying to create another string buffer object with the help of new keyword. So this is only the single approach. We have only one approach to create the string buffer object, and we have two approaches to create this string object with the help of using the new keyword and without using the new keyword. Now let's check the behavior of these two. So this is the string object, and let's see whether we are able to modify this string object, and this is the string buffer, and let's see whether we are able to modify the string buffer object. Just save it and let's try to. Now our assumption is that, so immediately our assumption is that when we are doing the concatenation here, Tashi Wangchuk will be printed. Then here also Sonam Wangchuk will be printed. So this is our assumption right now. Now let's try to check it here by compiling and executing. Java C test Java. Execute our test class. Now if you check here, so this is our output. So if we paste this output here, so we can see here it is only Tashi is being printed, whereas this Wangchu is not mentioned here, not reflected here. But whereas for the string buffer, when we are creating the object with a string buffer, we are able to modify this string object. For this, so this this behavior is called immutable. IMMUTAB, immutable. This behavior is called immutable nature. And here the output is Tashi. So we are not able to modify this string object. Now here is when it comes to the second object, this behavior is called the mutable nature of the class. Okay, string class. So here we are able to print Sonam Wangchuk. So this is just to show this the string behavior, that is immutable nature and mutable nature. Now in your college days, if you have performed exams in Java and all, so you might have given the question regarding this immutable nature and the mutable nature to answer. So if you give this simple code, then I think it's fine. So it means that you understand the meaning of this immutable nature and the mutable nature of the string class. Okay, so these points you have to remember. It's important. Now I think we are done with this case 3. This is the case 3. Yeah, guess this is case 3. Yeah. Now in the case 3 we have done this simple example. Let me just paste this here. So I hope you have understood what is this immutable nature and a mutable nature of the string and string buffer classes.